Welcome everyone to this explainer on mastering HVAC pressure switch diagnostics and repair. I am absolutely thrilled to have you here today. Look, if you're a focused learner trying to level up your real-world HVAC diagnostic skills, you are in the exact right place. We're going to break this whole topic down and give you a crystal clear, structured path to understanding exactly what goes wrong with pressure switches, and more importantly, how to fix them right the very first time. I mean, we've all been there, right? Getting that dreaded callback because a part was just swapped out and nobody actually found the root cause of the failure. It's super frustrating for the customer and honestly, it's frustrating for us. So today, we are ending that cycle. Let's dive right in.
So ask yourself right now, is your pressure switch really bad or is it just doing its job? This is basically the ultimate diagnostic question. I really want to shift your mindset today because, let's be honest, it is incredibly easy to see an open switch, go grab a brand new one from your truck and just swap it out. But we gotta ask, are you just a parts changer or are you a true investigator? A real investigator always asks why. They look at the evidence. By the end of this explainer, you're gonna have that exact investigator mindset, completely confident in finding the real root cause of the problem.
Here is our roadmap for today. We'll start with the purpose of the switch, look at the causes of switch faults, walk through a step-by-step troubleshooting procedure, hit on the golden diagnostic rule, and then wrap up with safety first and next steps.
All right, Section 1. The purpose of the switch, the baseline.
First and foremost, an HVAC pressure switch is a crucial safety device. It monitors pressure-related conditions and protects the overall system. Honestly, I want you to think of this little switch as the system's canary in the coal mine. It's just sitting there, constantly monitoring the environment. And the second things get dangerous, or even just operate out of the specified range, it sounds the alarm by opening the circuit. Now, it's not trying to be a nuisance, it's literally there to save the equipment from total catastrophic failure. Just think about what happens if a switch actually fails to open. An AC compressor can tear itself apart internally if liquid refrigerant floods back, or if head pressure goes astronomically high. Over on the heating side, a furnace heat exchanger could end up pumping lethal carbon monoxide right into a family's living room if a proper draft isn't established. This little component is your absolute ultimate fail-safe against those kinds of disasters.
Now, the most common applications you're going to run into in the field are furnace pressure switches and refrigerant high or low pressure switches. It's really important to understand how they differ. A furnace pressure switch operates in tiny increments of pressure. We're talking inches of water column here, basically proving that exhaust gases can safely escape out the flue before it ever lets that gas valve open. Refrigeration switches, on the other hand, well, they deal with hundreds of psi of liquid or vapor refrigerant pressure. So while they're monitoring entirely different types of pressure in completely different environments, their core job is exactly the same: monitor the conditions and protect the system.
Okay, moving on to Section 2, Causes of Switch Faults, the aha moment. The absolute most crucial point here is understanding the binary language of the switch. It opens or it closes purely based on pressure. Switch closed? That means normal operation. Everything is flowing, pressures are good, the system runs. Switch open? That means the system stops and you've got a fault condition. Let's picture a scenario, okay? It's Friday at 4 p.m. and you walk up to a completely dead rooftop unit. You throw your meter leads on the switch, you read 24 volts across it, which tells you the switch is open. The rookie immediately unplugs it, clips the wires, and just assumes the switch is bad. But here is the massive takeaway for today. An open switch does not automatically mean the switch is broken. Actually, far more often than not, an open switch means the switch is working perfectly. It's successfully reacting to a completely separate issue in the system to protect it. Assuming it's broken right off the bat, that's a huge rookie mistake.
So what are those separate issues? Let's break this down really quickly. Think about what drives up head pressure in cooling. A condenser coil completely packed with cottonwood and dirt, or a condenser fan motor that's thermal cycling off because its bearings are shot, those things will absolutely spike your head pressure. And that high pressure switch, it trips every single time in those scenarios to save that expensive compressor. Now let's look at heating. Restricted airflow from a homeowner who hasn't bothered to change their filter in a year, or maybe an inducer motor that's failing to pull enough of a vacuum. That will drop your draft pressure, opening that furnace switch to prevent an unsafe burn. Then you've got blocked pressure tubing, loose or damaged wiring, dropping the voltage, plugged pressure ports, you name it. Notice that way down at number 9 on this list is a legitimately failed switch. I mean, just look at how many other real-world system failures trigger that switch before we should ever even consider the switch itself as the culprit.
Right, let's get into Section 3, Step-by-Step Troubleshooting Guide, the procedure.
I want us to really absorb these initial steps because this is exactly where the detective work begins. Step 1, you must verify the fault code or the sequence of operation. Just sit back for a second and watch what the system is trying to do before you even touch a tool. Is the inducer even turning on? Step 2, use your eyes before your hands. Do a thorough visual inspection. Keep an eye out for melted insulation on wires or maybe water pooling near the draft inducer pan. Step 3. Check the wiring and electrical connections. A loose spade connector vibrating on a contactor can mimic a bad switch every single day of the week. And Step 4. Carefully inspect the tubing and the pressure ports. You'd be amazed how often a tiny little spider web in a draft port, or maybe a cracked piece of vinyl tubing, just drops the vacuum and causes a nuisance trip. Seriously, take your time with these visual and physical checks. Rushing right here is exactly how callbacks are born.
Continuing our methodical process, we move into the actual advanced testing. Step 5. Verify your control voltage. Look, if your transformer's putting out 18 volts instead of 24 under a load, all your safeties are going to start acting weird. Step 6. Use your multimeter to test the switch contacts for continuity. Step 7, and guys, this is where you really separate the pros from the rookies, verify the actual system pressure using proper diagnostic instruments. On a furnace, tee in a high-quality dual-port manometer to read the precise negative pressure the inducer is creating. On an AC unit, throw on your stubby gauges to see exactly what that high-side liquid line is doing. Step 8. Compare those precise readings to the manufacturer specifications. They're usually printed right on a sticker on the side of the switch itself. So, if the switch says it's designed to close at negative 0.6 inches of water column, and your manometer is only reading negative 0.2, well, the switch is fine. You've got a venting problem. And finally, Step 9, determine the true fault based on all that actual data.
Which brings us to Section 4, the Golden Diagnostic Rule, the wrap-up.
I want to let this next thought really sink in, and frankly, it should become your professional mantra. Don't just replace the pressure switch because it's open. First, find out why it opened. Seriously, repeat that to yourself every single time you encounter an open pressure switch in the field. If you just swap it out without finding the why, you are absolutely guaranteeing a callback, the customer is going to be mad, you're going to be frustrated, and you'll be driving right back to that same exact house the very next day. Find the why.
All right, final section, Section 5, Safety First and Next Steps.
There are some strict non-negotiables when we're dealing with safeties. First, always follow the manufacturer procedures. Next, always disconnect power when appropriate to protect yourself from an arc flash or lethal shock. And absolutely never permanently bypass a safety switch. I cannot stress that enough. We're talking about preventing lethal carbon monoxide from flooding a house or stopping a sealed compressor from violently rupturing under immense pressure. Bypassing a safety is incredibly dangerous, and it is just entirely unacceptable in this trade. Now, on a lighter note, for a practical next step, if you want a fantastic troubleshooting checklist to keep right on your phone or in your tool bag out in the field, definitely check out the Control Field Pro Etsy shop. The link is provided in the source description, and honestly, it's a brilliant daily workflow tool to keep your diagnostic process on track. If this explainer helped clarify your diagnostic process even a little bit, please hit that like button, subscribe to Control Field Pro, and follow us for way more real-world HVAC and controls troubleshooting. We absolutely love bringing this kind of structured, slide-based learning to you to help you truly master your craft. So I'm going to leave you with one final thought. The next time you see an open switch on a call, will you just swap parts, or will you actually find the real problem? You have the roadmap now. You know the exact steps. So go out there, trust your instruments, follow the logic, and be the investigator your customers truly need. Thank you so much for joining me on this explainer, and keep learning.